Howdy, everybody. How's everybody doing? Good, good, good. Well, we'll be hacking today, and I have 30 minutes to tell you about Hyperlane. So, Hyperlane is a developer platform enabling you to build what we call interchain applications. So, at the core of it, it's a smart contract API that lets you send messages from one smart contract on one chain to another smart contract on another chain. And so you might ask, why the fuck would I care? If you build an application today, this weekend, right, one decision that you will inevitably face is which chain do I deploy on? And that choice is pretty significant in our world in a way that it's not in a Web 2 world. Like, no one cares if you use like AWS or GCP, but if you choose Polygon over Avalanche over Ethereum, that comes with a pretty significant choice, and that's usually one, developer experience, right? Different tooling, different execution environments, those kind of things. User experience, so whatever chain you're on, all the users on the other chains, by definition, cannot use you. So you're basically forcing all of your users that are not on that chain to come to you somehow, and that's a pretty shitty experience. Another thing is platform risk, right? So like whenever you choose a blockchain, like you basically like all of the state of your application is completely dependent on the security of that chain. And then last but not least, value and network effects, right? Like if you, let's say, build a yield farming app on like one chain, but on that chain there's just like no other activity that you can kind of farm on, but like everything else happens on another chain, your application becomes much less valuable. And so like some people recognize this and they're kind of doing what we call like the copy and paste model, where you just deploy the same contract on every chain, right? So like Sushi and Uniswap did something like that, where they just effectively deploy a new application on every chain, like Polygon, Arbitrum, Optimism. But all of those instances of those applications are completely separate, right? So like when you use Uniswap on Ethereum, that has nothing to do with Uniswap on Polygon. And so there's no like network effects that your application gets from having state on another chain. Like if anything, it might actually be like vampiric, because like if you run liquidity incentives on, let's say, like Uniswap on Polygon, some liquidity from Ethereum might actually just move over to Polygon. And so what we believe is the future is what we call interchain applications, which are, again, applications that have smart contracts on every chain. And so users, wherever they might be, can use your application. And so you're no longer constrained by this kind of like forcing the user to come to you. Hyperlane itself is not a blockchain. It's built on top of all of these blockchains that we support, and it effectively eliminates the need to choose a blockchain. You can just be on every chain. And so we think, obviously there's a lot of ways of doing that. Like we think the first place to start is probably to allow basically your own smart contracts to talk to each other via Hyperlane. But you could imagine in the long-term future, there to be alternate ways of interoperability, basically. And so what we call basically the previous generation of interoperability, which was like asset-based, right? Like you basically like forced users to think of assets and how to bridge them. We think that applications will just be inherently cross-chain, and so it will be like an app-based interoperability. And so again, all in all, we think that's a better user experience. Of course, I think adding this is more complexity, and we can talk about that. So Hyperlane at the core is really just a messaging API, but we also provide what we call the accounts, the queries, and the token bridge API on top, which makes things a little bit easier. And yeah, I'm just gonna do the brave thing of trying to do live demos. So the first thing, the very base API that we have is what we call the messaging API. So on the sending side, you basically call what we call the outbox contract, called dispatch function with 3 very simple arguments. 1, the destination chain, so that's just like an ID for the chain. 2 is the recipient, so the address of the recipient. It's bytes 32 instead of address, because we eventually want to support non-EVM chains, which where the identifier does not fit into 20 bytes, and so that's why it's bytes 32. And then the message, which is just arbitrary bytes, whatever you want to send over. And then on the receiving side, your recipient just implements this handle interface, which basically like the system's Hyperlane contract will call, and it will basically call handle with, again, 3 arguments. 1 is the origin domain, so where did the message come from? 2, the sender, like which address on the origin chain sent this message. and then 3, the bytes of the message. So yeah, so that's pretty simple. And so if that's that simple, let's see if it actually works. So let's go. So on our docs, we have basic quick start tutorials for every API. And I like to think they're going to be simple. So let's try to go for it. So basically, first we have to find the outbox contract. So we have like in our docs here a list of like outbox contracts. So let's say here on Optimism, this is our outbox contract, and here is the dispatch function. So again, like what do? We have 3 arguments. One is the destination domain. So in here we have a list of destination domains. So let's maybe send it over to Fuji. We want to send it to a recipient. So we have pre-deployed like kind of sample recipients on every chain that you can use, or you can obviously send it to your own contract if you want to. So in this case, kind of BC3 or whatever is our test recipient. Actually, I can just show you right now on testnet snowtrace. Oops, remove the zeros. Is our test recipient contract, and it's like a pretty simple one. If I can find it, test recipient. All right, so it has a very simple handle function here that just emits the message and then like puts the sender and the data in storage. But so we can basically paste that in here, and then we can send a message body, right? So whatever bytes we want. So this is just in hex, so we can just say kind of like hello from ETHSF, copy and paste this in here, and then do the transaction. I'm pretty sure it should work. So we just sign it with MetaMask. Obviously, if you use Hardhat or Foundry or whatever you want, you just kind of send that transaction. And then you get this transaction hash. We have a message explorer that you can use to kind of follow along on the status of your message. It's explorer.hyperlane.xyz in here. And then whenever, there you go, when it was delivered, you can kind of check it out. The transaction is here. And you can kind of see that we received the message with our message on Fuji, on Snowtrace. And that's it. That's how you send a message from one smart contract, from, I guess in this case, Optimism Girly, to Fuji. And that was that simple. As I said, like like you saw, like the handle interface is pretty simple. So let's move back here. So that was the messaging API. That's kind of what we call our low-level API. And one kind of downside it has is that it requires you to basically have the recipient conform to a particular interface, right? Like the recipient needed to like implement the handle interface. But what if you could do better? And so like a common use case, for example, is like, what if you have, let's say, a DAO on Ethereum that wants to actually own, let's say, assets, or wants to like own contracts on another chain. Like with the messaging API, you would basically have to kind of like create this like proxy contract on the destination chain, which basically takes the message and then like performs the action on behalf of the sender. And so we just extracted that out in what we call the accounts API, which basically like deploys you with create2 a proxy account for any given sender address on any given origin chain, and can then do this for you. So the API looks a little different, and I'll get to it in a second, but kind of the benefit is basically that if you are like a account on Ethereum, you automatically have all of these proxy accounts on all these other chains that can basically like, again, own assets for you and then also do actions for. And so the interface is very simple. Again, it's like a dispatch like on our interchain accounts router. You have a destination chain, you have the recipient for which you want to make a function call, and then data, which is just the function call that the proxy account is supposed to make, ABI encoded. And so, yeah, again, an example is governance. You have a DAO, you want to do something there. And let's do a demo once again. So again, we have a quick start right here under the accounts API. So you basically just go, like in our case, you go to the interchain account router, which is right here and has kind of these two dispatches. You once again specify a destination domain. which let's just do Fuji again. So let me see what the destination is. This destination domain right here. And then this is like going to look a little bit more awkward in EtherScan, but like I think when you use like again hard hat foundry, it will be much easier. So basically, it's an array of calls, and then a call is really just like two things, right? Like the address that the call is supposed to do on the remote chain, and then the call data, which is the ABI encoded function call. And so let's say in this case, we basically want to call a function on the test recipient, which just happens to be foo_bar. It takes two arguments, a number and a string. And so if you, again, like wrangle the ABI, it just like ends up looking like this. So we'll just copy and paste this in here. And then let's connect Web3, MetaMask, yes. And then write. And then confirm, right? And so basically I am, what? I'm like 0xFAD on Optimism Girly. And so basically I can calculate the proxy address that this address will have on every other chain by just like calling a like predictable view function. So in this case, the sender, oops, that's not what it is. Copy and paste my address in here, right? Like my sender is on Optimism Girly, so the origin, I think it's 420 on there. And so basically the interchain account address, which again is the address from which the calls will make on every other chain, is like C7BA blah, blah, blah. So let's look at our transaction here. Take the transaction hash. Let's put it in Explorer again. There you go. And what you can see here, for example, the Explorer will actually like decode your message and will determine like, hey, you are the sender. That means that when the message gets processed, this address, your proxy contract, will make a function call to this destination address with this call data. And so if you look at the block explorer here, you will see that on Fuji, kind of like here, C7 basically made a call to our test recipient that we specified, and then the test recipient just emits this event that basically says like, hey, like I received this call from my proxy account, right, C7BA, and with these messages. And so we think that's another like nice API because you don't actually need to deploy anything on the destination chain. You just like from the origin chain can basically like own things like contracts or assets on the remote chain via this proxy account. So that's the accounts API. Another use case that we found that we wanted to make it easier for developers is, let's say you are on Polygon, but you want to like make a view call on Ethereum, right? Like there's some state, let's say you want to like know the price of the like Uniswap V2 twop of like ETH or DAI or something. But you're on Polygon, how do you do that, right? And so like what you could do is you could deploy a contract on Ethereum and Polygon, send a message over, that contract makes a view call to the Uniswap twop, and then like sends back a message back to Polygon with the results of that view call. And so again, instead of like making you deploy these contracts, we've just decided to like make a similar kind of like router contract that just does that for you. And so basically in this case, what you do is you call our query router with your query, right? Like of basically the destination chain, which like target you want to hit, and like what's the view call. And then we'll basically do the hard work of sending the message over, making the view call on the destination chain, and then returning you the result in the callback that you specify. And so the API looks a little bit like this. So you do query, destination domain, the call that you want to make yourself, and then again, like specifying like what function should the router call on the origin chain for you. And again, on the destination chain, you have to specify nothing, right? And so there's like, I guess we have here an ENS example if you want to like kind of resolve an ENS name from a different chain. But let's just do once again the demo. So we have another quick start right here, queries API. Basically tells you to just navigate to the test query sender. So we'll go right here. Actually, let's take a quick look at the contract. Test query sender. Right, so basically what you can do is like query an address, and all it does is really kind of pass through the destination domain, the call, and then it just has like a handle query address result function on itself, which the router will call whenever it gets back the result. And so let's call it right now. So again, let's connect MetaMask. Let's query an address. And so once again, let's just query, what do we want to query? So we can just query this like content that we have, and we can just kind of query for the owner of it. And so let's say the owner call ABI encoded is this string. Once again, let's figure out which destination domain you want to hit. Let's just do Fuji again because it's been working so well. And then rewrite it. We confirm. And then this transaction happened here. Once it is reflected, once EtherScans puts it up, I think you will see kind of, here, query dispatch, right? Which basically means like, hey, we sent a query over there. Once again, we can use our Explorer to, we can use our Explorer to see where the message is at. Oh, and was already delivered, right? So this is the first transaction where we sent the query over. On the destination chain here, when the message gets processed, we make the view call, and then actually we send a message back. So this is what we call the dispatch event, right? So we basically return the query with the result, which means that this transaction hash, actually like the destination processing of the message itself, is actually another message. And so we can see that here. So there's basically kind of this return message that now sends back the query result back to the origin chain. And then once that is done, on here, you can see that the query was resolved. And actually, if we look right here, requery, we can see basically what the test query sender will just persist the result in storage, and that's what it is right here. So that's our query API. And then last but not least, one of the things that people ask us a lot about is like, so how do I move value, right? Because a lot of this things was basically information, but like what happens when you want to move value? Let's say if I have like some yield farm on like Polygon, but I like actually see there's another yield farm that's really cool on, let's say, Arbitrum, like how do I move this as a developer? And so it's a pretty tricky topic. Like definitely come talk to me afterwards if you're interested in like the nuances of that. But basically we have this token bridge API, which allows us to wrap other token bridges to basically move value around, right? And so Circle, for example, announced their native USDC bridge where you're allowed to like burn USDC on one chain and mint it on another. And so basically we let you do that within the same interface because we believe that there will be many different bridges that you can use. And right, like Circle is only going to be available on some chains, but what do you do on other chains? And so we will just have this kind of single interface that allows you to move value around. And it's, again, pretty simple. It's literally just dispatch with just tokens. So basically just like specify the token address, the amount, and then the bridge name. So for right now, it's only Circle on both Girly and Fuji. And then on the destination chain, you can handle that message with the token address and the amount. All right, one last demo is for the token bridge API. So this is USDC on Girly, right? And so one thing we need to do is we need to approve the token router with some USDC. So let's switch over to Girly. Let's approve. The spender will be our token bridge router. So we'll copy that in here. Approve, let's say just one because we're stingy. We'll approve the router here, and which now means that we can dispatch with tokens. So let's again send to Fuji. I still didn't remember what the domain is for Fuji, so let's just, Fuji is 43.113. Recipient address, we just have, again, like pre-deployed recipients, but you can obviously use your own. So that's right here. The message body, again, we can put whatever we want. I will just say the classic hello world, which is, where is the message? All right, here. The token is the USDC address. So like that's this thing right here. Amount, let's just do 1, and then the bridge. in this case, a circle, or again, whatever other bridges we will use in the future. Got to connect MetaMask, and then write that, confirm. All right, and then the transaction is once again here. Once it gets mined on Girly, Girly works surprisingly well, and as everybody knows here, Girly ETH is very hard to get, so be, careful. Okay, let's take a little longer. Let's again look at the Explore. I think maybe, hopefully Girly won't be too content today, but it's still indexing. There you go. All right, so now you can see here kind of how this USDC was burned, right? Like to the 0x0 address. And then like once it gets processed here, oops. Oh, this is what happened in 1 second. Or maybe 2 seconds, I guess. But it will happen in 1 second, I'm pretty sure. I mean, if this is literally the last thing. If this fails, this will be like I was so good about live demoing this. But maybe, yeah, before we get to it, I guess, at the end, obviously I'm going to be happy to take questions. We'll have a booth all the way at the beginning. We'll be here all weekend. Obviously happy to chat or help out with anything. We'll have 4 bounties, kind of like best use of Hyperlane, as well as kind of like best NFT use, best DeFi use, best gaming use as well. Yeah, but I want to emphasize that we're here to help. We think that the cross-chain future is very bright, even if we're very early. And you could be one of the first people to kind of build these cross-chain applications, because we just think everything will be a cross-chain application in the future. And I would love to end the presentation. Oh, there you go. And so you can see that we minted some USDC to our recipient, and our logs basically said like, hey, I got this message, hello world, and from this token. Yeah, so I think that's it. Yeah, any questions?